In this example, we'll run the MNIST deep learning network in a Jupyter notebook, and we'll also show support for TensorBoard in the Hopsworks platform. So first we'll log in with the default password, and what we can see here is that I've already run we've already run this deep learning tour. It created this project over here called Demo Deep Learning, and I'm going to go straight into that particular project. And in this project, you can see that I'm going to select the Jupyter option up here because we're going to start the Jupyter notebook, and I'm going to train the network using a Jupyter notebook. Now I'm going to start with the default options that we had from our first example, where we can press start. We're going to have 2 gigabytes for the driver, 4 gigabytes for the executor, and 1 GPU for the executor. I'm pressing start now. That will start our Jupyter notebook running. It will start in a new tab. You may have to approve this. And now I'm going to select experiment here, and now we're going to TensorFlow, or in this example we're actually going to select Keras. And I'm going to select the MNIST example for Keras. And in this particular example, if we go through it, we can see that we have the same patterns we had in our first video, where we have a function. In this case, the function is called Keras MNIST, and the function can have any name you like. You could just pick your own name for the function. And now we have the same code that we had before for training MNIST in the first example, but the difference here is that we're now going to introduce support for TensorBoard. So just to show you that the code is the same as before, we can see that in this time it's slightly different. We're launching the Keras notebook with this Keras MNIST function. We're storing a name for it, and we're calling experiment.launch. We're not using Maggie, we're just using the experiment support in Hopsworks. So let's look at how we add TensorBoard support here. So the first thing we need to do is we need to import TensorBoard from the Hops folder, and then what we can do is, if we move further down the example, we can see that when we let's have a look here. We can see when we define our callbacks, we need to have callbacks for Keras. What we're doing is we're telling Keras, the callback function for Keras, that we want to store TensorBoard logs in a directory called TensorBoard logdir, and that will appear in our dataset folder in Hopsworks. And then we have some other options. We want to write the images, write the graph, and the histogram frequency will be 0. And then we basically decide where these TensorBoard log files will be stored in the TensorBoard logdir that we'll look at later on. And then finally, this callbacks that we've defined here, we'll pass it as a parameter to the model fit function in Keras, and that's all we need to do to actually add support for TensorBoard. So now that the PySpark application started running, we can start the training. And in this case, you can see we also have a new line here which is saying notebook. Oops, let's get rid of that. The notebook this is the notebook that we're actually running, and it will get stored with our experiment. And we'll notice also that the logs aren't being printed out directly to the screen. So in this particular example, we're not using Maggie, which prints the logs out directly to the screen. In this case, it says the experiment is finished. And we can go back to Hopsworks, and from here we can again look at our user interface for Spark to see how things progressed. And we'll click on that blue button now, and we can see here that we have the executors the same as before. We have a driver, we have the executor down here, our driver and our executor. We can look at the logs of the executor, and it's similar to before. So everything looks pretty similar to before, but one thing that's happened is that if we go back and refresh our notebook here, we can see that in the experiment section we have the experiment succeeded. It was using the experiment launcher rather than Maggie. And in this case, we had support for TensorBoard. So what we should be able to do is take this application ID, paste it in here, and then we'll get the TensorBoard in the user interface. Now, if you want to see the TensorBoard while the application is training, that's also possible. So we'll just look at the TensorBoard launching first. And we can see it here. And in this case, we can see that the prediction accuracy increases up to around 95% pretty quickly, and then stays quite constant. You can spit this out into a new window by clicking up here, which often is quite a useful thing to do, because then you just have your TensorBoard in its own window. And TensorBoard has its own features. You can look at wall time instead of step time. And finally, what we can do is we can go and look at where those TensorBoard log files were written out. So we have this datasets folder here, and the output is written to the experiments folder here. Now I ordered them by last modified to get the most recent one. This is the application I just ran. We can see it says launcher. It was the first run. And here we can see there was a checkpoint written out. So there's 2.8 megabytes of TensorBoard directory data written out there that we're using to visualize. Thank you.